Hello, this is Ali from WWF Pakistan, and we aim to conduct this feasibility study for the heat pump solutions, which is to be implemented at the denim mill in Karachi, Pakistan. The name of the business entity is Artistic Milliners, and it's a renowned textile exporter in the country. A bit of about WWF Pakistan. So we are the largest nature conservation organization in the country. We are operating since 1970. We are a known name in terms of environmental conservation and nature conservation, and we work with the leading brands across the world, and we work with corporates, we work with major stakeholders. Our works expanded from the species and habitat conservation. We are the national leader in the industrial decarbonization, climate resilience, and sustainable production. And we believe in partnerships, and we believe working with multiple of stakeholders and bringing change in the supply chains, and we aim to bring long-term change through policy interventions for a low carbon future. So here is our project team. We are a team of diverse people who are technically quite sound, ranging from textile engineers, environmental engineers, energy auditors, GHG emission experts, environmental analysts, and we are placed in major industrial hubs of the country. The solution that we propose is that we want to bring about the change from and diverting the load from the fossil fuel based energy demand to the electrification, and our electrical grid is low emissions, so we want to have the heat pump integration as a scalable and cost effective decarbonization strategy for Pakistan's textile sector, which will ensure economic, environmental and reputational gains. So the primary objective of the solution is to shift thermal loads to the electrical loads, because the thermal loads result in higher GHG emissions in contrast to the electrical load, which is mostly based on renewable energy or from the grid, and the grid has lesser emissions because we have a greater chunk of production from the renewables. So one of the potential improvement area will be the deployment of heat pump solutions in the denim processing. So the grant project aims to conduct a detailed feasibility study which will comprise of site visits, meeting with the project team, collecting verifiable data, and we will be analyzing and conducting the on-ground surveys, and then we will carry out the engineering sizing of the heat pump solution, the right size, what size it will suit for the electrification, and then this engineering design will help us assess if the proposed solution will be economically and environmentally viable or not. If the heat pump solution is found feasible, the project team will then provide implementation support to the denim mill through the vendor selection. We have done our base work, research, and we are better positioned because we have a background of carrying out environmental energy audits in more than 100 leading exporters in the country in the past decade. So at the performance review, and then we will build a business case for the wider uptake, because we have direct liaison with many of the textile associations in the country, and we believe that there is a greater chance of scaling up this solution for the wider uptake to the entire sector in their value chain, starting from the ginning, the weaving, then the textile wet processing, garmenting, and then cut to pack solution. So in the entire value chain, starting from the processing till the finished good, there is a great potential of environmental improvement and in terms of GHG emission reduction. So here is our project plan, the Gantt chart, which shows the list of activities that will carried out. The first of the activity will be site investigations and data collection, and then we will proceed towards on-ground energy audits, which will be carried out at the denim mill situated in Karachi, and then the feasibility study and cost benefit analysis will be done. where we check the ROIs, the system design will be done, what size of heat pump will be suitable for electrification, what GHG emissions will it offset, and how will it go beyond the conventional solution. Then the vendor will be engaged and the project will be executed post the month 6 from to month 11. And once it is done, we will have the performance evaluation of the heat pump and the solution. Once it is there, it has to be evaluated and the performance reports will be generated to see if it is going to deliver the intended outcomes. And at the end of this performance evaluation, we will develop a business case with the project sites team, and then we'll have that dissemination sessions for the wider audience so that they can take it forward and they can deploy it at the next level. The effectiveness is that a baseline assessment will be done to analyze the resource consumption profile and heat pump feasibility and implementation support. So we'll be making use of the energy auditing guidelines, energy efficiency protocol, environmental performance evaluation, ISO 14031, and then GHG calculation through the ISO 14064 standard. So we propose a phased data-driven and stakeholder-inclusive methodology for the feasibility so that we can have the best solution on board. This gives a picture of the different areas available, the overall energy and material map of the entire facility where we want to conduct this study. So you see here the natural gas consumption in terms of cubic meter, then the kilowatt hour electricity consumption from the KE. KE is the Karachi electric grid supply, and then there is solar PV electricity generation from solar PV as well. So currently the natural gas is being used to generate steam through the boilers, and then that steam is being used for water heating and other sources. And then the electricity is being used for space cooling, which is the business as usual. So here the gas and steam consumption data is on annual basis, and we have retrofitted it to represent the operations of 1 month. So this entire sheet represents the data of 1 month basis, so that we have the unit consistency. So the reach is that we want to have the hotspot area of wet processing. We are targeting that area, and the only thermal energy is being targeted. You see in this side the thermal energy, there's a great potential. If we reduce the use of natural gas, then proportionally the GHG emissions will be reduced, and the organization will be able to save electricity and the cost. So the facility will offset the GHG emissions resulting from the natural gas consumption in the thermal side. So there is a great potential and prospect to scale this, and there will be energy assessments to consider low grade waste heat as a valuable asset, and then local vendors will be utilized for heat pump solutions so that this is not just one case, rather this is implemented across the value chain and across the sector in the country. So these are the financial asks. The details are also put up in our financial document which we have submitted to the Parallel Impact Institute, and mostly our work will be on the experts that will be deployed to carry out the investigation, site calculation, energy assessment, feasibility study, and system design. And some budget is being allocated for the boarding and lodging to accommodate the expenses that are required. And in all we have requested 14,990 US dollar for this study so that we can carry out this and reach the ultimate objective of assessing the suitability of the heat pump for the textile sector. So these are the major deliverables and their milestones have been given. The key milestones are a site assessment report in the beginning, then we'll have a detailed energy audit report, Once the audit report is there, we will have the detailed feasibility report, which will comprise of a simulation of heat and mass balance, modeling the heat pump performance for steam production, because the steam is the major chunk which is used in the textile in the thermal side. And then the comparative analysis will be there, with the capex, the opex, and ROI. The economic side of the project will also be explored in this report. Once if the solution of heat pump is termed feasible, then we will move towards a system design, taking into confidence the Apparel Impact Institute as well as the client, which is the artistic milliner. And then we will move further, where we will have the detailed design and measurement and verification methodologies, the guideline for floating EOI, and minimum criteria for selecting the vendors. Once this is through and we secure the funding for implementation of the project, then the vendor will be engaged. Vendor will be selected based on the criterion given in the feasibility report, and the technical aspects, after sales services, their performance will be analyzed, and then the final vendor will be selected and mobilized to deploy the solution. Once the heat pump solution is in place, then from months 12 to 16, the performance will be monitored on periodic basis. We will have the measurement and validation of the achieved benefits, and then identify further optimization opportunities. Once this is done in the month 17 and 18, the final 2 months, the technical results will be shared and the case study will be developed to for wider dissemination, so that the other textile sector major role players, the export sector, they can get benefit, because there is a great thirst and demand for different textile sector notable representatives in the country to move towards sustainability initiatives, and this offers a great promise for them. So that's all, and we aim that this solution, this proposition has a great potential towards upscale and faster uptake by the industry leaders. Thank you.